Thank you for this introduction and good afternoon. It's very exciting to be in front of a full house. I don't know if this can be attributed to the free meal or to the topic or the speakers, but let's say it's because of the speakers. I've been given the role of talking about dairy in health. I will focus primarily on cardiovascular health because this is my area of expertise. And I want to first disclose my relationship with funding agencies, including Dairy Farmers of Canada. I think disclosures is becoming a sensitive issue many times when we present now, so this has to be clear. I have no stocks in dairy. I have to mention that as well, and I have no gain if people eat more dairy or less dairy, personally. I am at the service of the science, and I let the data speak. I have no interest in defending one opinion or the other. For me, it's the data that decide what we need to do. So dairy products are part of our guidelines. Most guidelines around the world, actually, and this is the case in Canada as well. We recommend a number of servings per day, depending on age. And most of those recommendations are based on low-fat dairy. So there is a lot of science behind these recommendations, but there's also a lot of dairy intake is deep-rooted in many of our cultures, and this is one example, of course. But there's a lot of polarized discussions also around dairy, and the population is exposed to websites like this, and this is just one example, but I was just curious before the talk. I was going over the web and just looking at, you type on Google milk sucks and you find thousands of web pages that give you, thousands of reasons not to drink milk or to eat dairy. So it's interesting because the science is very strong around dairy, not strong in terms of where it's going, but we have a lot of information on the impact of dairy on various health outcomes. And then there are these perspectives that are promoted, and so I was interested in trying to see, well, do these people have a good reason to say something like this? Or is the science really going in the other direction, saying dairy is healthy or should be part of a healthy dietary pattern? So what I intend to do in the next 40 minutes or so is to provide you with my perspective on the available data that we have to put dairy in a healthy diet paradigm. Where does it belong, and if it does belong to a healthy paradigm? So one of the main reasons why, irrespective of your environmental perspective, of your personal interest in food, one of the main reasons why dairy products have been criticized, is their contribution to saturated fat intake. And we have a long history going with saturated fat intake, and there's a discussion this afternoon on this as well a little bit later. But certainly dairy does contribute to saturated fat intake, and cheese is one of the main contributors. Its contribution is pretty small. It's about 8-10% of total saturated fat intake. Milk is there, in the lower end of the pie chart. But this is one of the many reasons why people have been saying, well, we shouldn't take too much dairy and we should actually consume low-fat dairy. So what I'll try to do is give you some perspective on this particular topic. So does dairy belong in a healthy dietary pattern? And I'll use 3 different approaches: the cohort data, the randomized clinical trial data, and also other perspectives. And it's actually a good idea that Dominic spoke before me, because he presented a number of things that are very relevant to what I'm going to be talking about. So this is one example relating dairy and saturated fat to cardiovascular health or cardiovascular disease. So this is a cohort of about 5,000 people, the MESA study, with a 10-year follow-up, where they looked at the relationship between various sources of saturated fat and cardiovascular disease risk. So in that particular study, intake of saturated fat was actually inversely related to the risk of cardiovascular disease. This is counterintuitive, but this is what they were observing. And this was mostly attributed to saturated fat from dairy, which were also inversely related to the risk of cardiovascular disease. And then meat was on the positive side, so saturated fat from meat tended to increase the risk of cardiovascular disease, and it was a mixed picture with the other sources of saturated fat. So it seems like there might be something within dairy that may actually attenuate and perhaps even drive the association between saturated fat from that particular product towards a beneficial effects on cardiovascular health. Now, this is a very small study, 5,000 individuals based on food records. We know the bias about this. So this is a meta-analysis that was published about a year ago. And what they did is they looked at observational studies using self-report diet records. They've looked at also observational studies that have used biomarkers of intake instead of relying on self-report data, and also on randomized controlled trials for specific fatty acid, most prominently with N3 fatty acid. So this is a very, very high quality meta-analysis. And as Dominic pointed out, when you do meta-analyses, you're stuck with the quality of the individual studies. So if each of the individual studies are flawed, your interpretation of your meta-analysis cannot be excellent. It's based on flawed data. So this actually, and the quality of the meta-analysis, it can also be graded, can also be assessed. So this meta-analysis, when we did our own review of the literature, was the best meta-analysis available in terms of quality. It rated 100% on score in terms of quality. So what they've done is they took studies that had measured fatty acid concentration in the blood of participants and reported the association with the risk of cardiovascular outcomes. This is coronary outcomes, and total saturated fatty acids in the blood did not correlate with coronary outcome in that particular study. However, saturated fat in the blood is not necessarily a good marker of saturated fat in the food, so we can discuss that a little bit later. However, they saw an inverse relationship between a specific saturated fatty acid, decanoic acid, a 17-0 fatty acid, which source is mainly from dairy fat. So this is another suggestion that dairy intake, if we assess it through its contribution by dairy fat, may be inversely related with cardiovascular outcomes. So this is one meta-analysis, and we've decided to try to contribute to this field by looking at the whole spectrum of data we have in this area, and it's really building really, really fast. So we're actually in the process of finalizing a huge review of everything we have at hand right now, including reviewing all of the meta-analyses that are available on this particular topic. And I can tell you it's quite some work to achieve. So the next few slides are all built around the same pattern. These are the results of our analysis of the existing evidence relating dairy intake with cardiovascular or any clinical outcomes. So each dot represents data from one meta-analysis, okay? And therefore, behind each dot, there might be between 4 and 15 studies, including between 30,000 and 500,000 people between each dot. Behind each dot. So what you have is the association between different dairy intake, total, high fat, low fat, dairy fat, when they are measured by biomarkers, milk, cheese, yogurt, fermented products, and the risk of different clinical outcomes. And you'll see, what we're looking at here is different patterns of associations. Are they all protective? Are they all increasing the risk? Or are they all neutral? And there are different colors because these represent different meta-analyses. So if you have two dots with the same colors, they come from the same study. So basically for cardiovascular, total cardiovascular disease risk, mortality, incidence, and so on, what we see is no significant pattern of association from these meta-analyses. They're all towards the one value or towards a protective effect. But there is, for milk, for example, it seems to be 2 out of 3 meta-analyses suggest that it's protective, 1 suggests it's not. And there are different approaches that the authors have used. Some are dose response effects, or more comparison of quartiles and so on. But certainly no studies, meta-analyses suggesting an increased risk. Now, you look at the meta-analyses, you look at all the data that they have used, the authors have used to conclude and to do their analyses. Now, and I'm sure nobody can see anything on the slides, and that's on purpose. What I want you to focus on is the red bars. So there are studies being published almost on a weekly basis on this topic. So meta-analyses published in 2011 is not updated compared to what is being published since then. So these are, for example, for cardiovascular disease outcomes, the recent studies that have been published that are not included in the existing meta-analyses. So what you want to see is, if you add up data to existing meta-analyses, is that going to change the risk estimate? Or is the risk estimate pretty well secured and it's not going to move any further? So some of these studies are fairly small, 100,000 individuals. Some include 120,000 individuals, 100,000 individuals. But the main, if you look at milk in that particular case, there was 3 out of 4 new studies. There was 1 that increased, that showed an association between milk intake and the risk of cardiovascular disease outcomes. And this was a study in Sweden that got a lot of press, showing that actually milk intake was increasing the risk of fracture and increasing the risk of cardiovascular disease. So this is based on data from about 100,000 individuals. So one would say, well, maybe this study will change the risk estimate of dairy and cardiovascular disease risk. But this analysis is based on 500,000 individuals. And when you take into account all of the new studies that are being published and you include this one, it's very unlikely, because the estimate is very small, that it's going to change the total effect of dairy versus cardiovascular disease. So the worst case scenario, it's dairy is neutral in terms of cardiovascular disease risk, total cardiovascular disease risk. If you look at coronary heart disease risk, each dot is a meta-analysis comparing the contribution of different dairy to the risk of coronary heart disease. Again, I guess the main pattern of distribution is a neutral effect, perhaps with the exception of milk, where there tends to be a protective effect on coronary heart disease risk. All the other ones are fairly neutral in terms of their results. If you look at stroke specifically, again, most of the association seems to go on the protective side. I remind you, these are all systematic analysis. These are, each dot represents data from 4 to 20 studies, cohort studies. Milk, again, seems to be on the protective side, with the exception of 2 meta-analyses out of 4. One other thing I want to emphasize is, if you have 6 meta-analyses on one particular topic, milk versus stroke, there's a lot of overlap in the studies that these meta-analyses have used to conduct their study. So they may share 20, 50, 80%, or even 100% of the cohort studies among themselves. So it's normal that they reach the same results. They're reviewing the same studies. In some instances, it's not always the case, depending on your inclusion criteria and so on. But nevertheless, there is a pattern, and it's either neutral or protective. For example, for the low-fat dairy intake and for total intake, the 2 meta-analyses suggest that this is protective in terms of stroke risk. Fermented, there's only 1 study going into the protective direction. So again, no indication that high-fat, low-fat, total dairy, milk, cheese, whatever, increases the risk of stroke. Hypertension, this is an area where there's a lot of interest. There's clinical studies on hypertension and dairy. Again, low fat seems to be protective in terms of preventing hypertension. This is all cohort studies again. Milk also, total dairy as well, based on 2 meta-analyses. No effect of cheese, no effect of yogurt, no effect of fermented products. So specific dairy products may be associated with a reduced risk of hypertension. No dots on the +1 side of the graph. Type 2 diabetes, a lot of studies. Yogurt seems to be protective. This is quite consistent between the different meta-analyses that are available right now. Low fat is very consistent also. Higher consumers are at lower risk of type 2 diabetes than higher consumers. In that particular case, in the diabetes scene, these meta-analyses actually share a lot of cohort studies. So they come to similar conclusions, but they actually analyze the same studies. So it's not entirely surprising. So you can actually assess the quality of the evidence based on different criteria to make a judgment on an association. And there are different criteria to use. This is one of those. It's called the grading of recommendation, assessment, development, and evaluation. And you use that to make recommendations. So should we recommend the consumption of dairy? Should we recommend the consumption of whatever based on specific criteria? Now, because we're just assessing the quality of evidence relating dairy to health, I've used this not for recommendations, but specifically to assess quality of evidence. So there are 4 levels according to the grade scale for quality of evidence. The high quality of evidence defines a situation where further research will not change the risk estimate. It's already in the cement. It's very, very strong, and it's not going to be changed by additional studies. It's very consistent. Moderate quality evidence suggests that further research is likely to have an important impact on confidence, so it might change the risk estimate. And you have the low and very low quality evidence where basically you don't know. So you can't draw a conclusion on this association. So if we take the data we have and we use this grading system to assess the quality of evidence relating dairy to different outcomes, this is what we come in terms of conclusions. So there is high quality evidence from meta-analyses of a lot of studies, a lot of people, that there is a low risk of stroke, hypertension, and type 2 diabetes with total dairy consumption, and low risk of type 2 diabetes with low-fat dairy consumption and yogurt consumption. This is based on high-quality evidence. Moderate quality evidence, so the risk estimate is favorable, but may change with additional studies. Lower risk of stroke, hypertension with low-fat dairy product, low risk of hypertension with milk, and low risk of type 2 diabetes with cheese. This is moderate quality evidence. There is also high quality evidence for a neutral effect of total high and low fat and milk and cheese on coronary heart disease risk, milk versus stroke, cheese versus hypertension, high fat dairy, and milk versus type 2 diabetes. See, this is unlikely to change in the future. Moderate quality evidence of a neutral effect of total dairy and cheese on CVD, yogurt on CHD, and so on. So this is our appreciation of the existing evidence we have relating cardiovascular disease, stroke, hypertension, type 2 diabetes to dairy consumption. But I want to emphasize that there is in none of the cases we've looked at, there is a high or moderate quality evidence suggesting that dairy has a detrimental effect on any of these clinical outcomes. So any form of dairy does not appear to have an effect on CVD, CHD, stroke, hypertension, or type 2 diabetes. Now, this is based on cohort data, and we've talked about the limitations of such analyses. This is based mostly on self-report data, so there's a lot of bias. Is that based on one measurement, repeated measurements over time, confounding effects? You can adjust for BMI, you can adjust for smoking, but there's residual confounding that's out there. So, and we're never going to have a one or several studies, randomized control studies with clinical outcomes assessing the effect of dairy intake, whether it's milk or cheese, on cardiovascular or type 2 diabetes as an outcome. With a big, 100,000 individuals randomized to X and Y. So this is the best data we can rely on in terms of cohort study. But we can turn to randomized clinical trials using biomarkers of disease that are recognized to be associated with the risk of heart disease, for example, LDL, HDL, ApoB, and so on. So, and there are a lot of those studies that have looked at dairy consumption and biomarkers of disease. And LDL cholesterol is a good example. There are 6 to 8 studies now that have come to similar conclusions, despite a higher contribution of dairy to saturated fat compared to a pure source of saturated fat like butter. Dairy does not increase cholesterol. So this is one example of a study where people have consumed in a randomized controlled fashion a lot of cheese, contributing to about 30% of saturated fat in the diet, or a lot of butter, same amount of saturated fat. LDL goes up with butter, doesn't go up with cheese. So there is something in dairy that alleviates, that attenuates the impact of the saturated fat on cholesterol. Now, this is not disease measurement, but it's certainly using a specific biomarker that is recognized as a marker of cardiovascular disease. There is one meta-analysis by Benatar from New Zealand who has looked at one of these studies, like the ones intervention studies where dairy was used, and saw no systematic effect of low-fat or high-fat dairy on cholesterol levels. So the summary risk estimate is not significantly different from one, indicating that the effect of dairy from those clinical trials, randomized trials, is insignificant. So dairy doesn't seem to have an impact on LDL cholesterol levels, whether it's low-fat or high-fat. And actually, the same meta-analysis looked at insulin, looked at hypertension, looked at a number of outcomes, and they came pretty much to the same conclusion. So one can look at cardiometabolic risk using different risk factors. This is not clear indication of future disease, but this is the best we have in terms of surrogates of disease. And we can argue on whether HDL is a good surrogate for disease. We can argue on inflammation and so on. But certainly we can use these data to better appreciate the effect of food on the risk of clinical outcome. And we've looked at inflammation specifically in a systematic review of the studies that have investigated the impact of dairy consumption on inflammation markers and randomized control trials. And we also did a study that was just published on this. But basically what we saw is there are a few studies, only 8 or 9 studies that have looked at inflammation and dairy in a randomized clinical trial. The only one that was done primarily to assess the impact of dairy on inflammation showed a protective effect of dairy consumption on inflammation. Now, there are a number of other studies that have looked at that, but they were not designed to look at that specifically. I'll give you one example. In one of these studies, they had 20 subjects. You don't have enough subjects with 20 to look at inflammation. You need more people than that. So it's not surprising that you don't see an effect if you are not powered to look at that effect specifically. But nevertheless, it's at worst neutral in terms of inflammation. So our study is pretty much aligned with these results. So we did a large study specifically designed to look at the effect of dairy consumption on markers of inflammation. We use commercially available dairy products, milk, cheese, and yogurt. And compared to control products, dairy-free control products, which in terms of a healthy dietary patterns tended to reduce CRP and IL-6, we had similar results with dairy, although just the reduction in IL-6 was significant. So it seems like it's at worst neutral, and maybe some anti-inflammatory effects of dairy on some markers of inflammation. So you can look at cohort study. There are a lot of bias, and we have to live with these bias. You can look at randomized controlled trials where you can measure surrogates of risk. And now it doesn't mean that because you change LDL or because you change HDL or because you change systolic blood pressure that you're going to have an effect on future disease risk. But this is another approach that can be used. And in both cases, the effect of dairy seems either to be favorable or neutral. Other considerations, and I think these points are important. So we've talked about replacement, and in epidemiological studies, What you do is you look at the relationship between intake of dairy using quartiles, for example, of milk and the risk of coronary heart disease. In clinical trials, you're going to look at replacing milk with juice or milk with water or milk with soy beverage, and you can see the effect of one versus the other. So it's important to keep that in mind, because for dairy, this is an important issue. What do you compare dairy with, and what is the right comparison for that? So, and we've talked about some of these studies, and I tend to agree with Dominic. This is very tricky in epidemiological study to say, well, this is the risk associated with dairy, this is the risk associated with meat. One minus the other gives the risk associated with a replacement. This is purely mathematical assessment. But some people do that. These are data from the Nurses' Health Study in men and women and health professional study. And what they say in that paper is that if you replace whole fat, if you replace whole fat by meat, or the other way around, actually, your risk is lower. And it's the same for high-fat dairy. So high-fat dairy and low-fat dairy is better than meat in terms of cardiovascular risk. Okay. This is for stroke. This is for CHD, and they have a similar approach. So again, as for stroke, does this work? Yeah. So high-fat and low-fat appears to be better than red meat, but high-fat dairy is not good compared to fish. So if you replace milk or high-fat dairy by fish, you increase your risk of heart disease. So again, this is purely mathematical consideration. But we don't drink fish, okay? Or we don't drink nuts, although we can drink almond drinks. You cannot statistically compare nuts with milk. This is not the same context of consumption. This is not the same purpose of eating. So we have to keep that in mind, because this is a purely mathematical substitution, and we need to consider, well, what happens when we replace milk with another drink, which makes sense from a diet perspective. I'll show you one study that was published 3 years ago, where they actually fed people 1 liter per day of Coke, of partly skimmed milk, of Diet Coke and water. So this was a fairly small study, about a 40 or so individual study, 10 or 12 in each group, and they looked at the accumulation of fat in these people using imagery. And what they saw is milk compared to the regular Coke was associated with lower beneficial change in visceral adipose tissue, as well as lower levels of fat in the liver compared to the regular cola. So for me, this is a real replacement study. If you don't drink milk and you drink Coke, what happens? It's not if you drink milk versus if you eat fish. We can't compare those two. The milk group, 1 liter per day compared to the Diet Coke and the water had essentially the same effects on visceral fat and liver fat. So this is a good replacement study. This tells us what happens if you switch one and you replace it with something else. And the effect on blood pressure was about the same also. So favorable effects of milk, 1 liter per day compared to Coke. This is not this is not rocket science. Okay, we probably would have bet on those results before the study began. But they show that what we're expecting, and they demonstrate replacement effect very clearly. So what's my overall perspective on this? I think there is no evidence whatsoever that dairy, in terms of cardiovascular, cardiometabolic health, poses a health risk. One thing we tend to do a lot these days, and this is pushed by us researchers, but also by the media and so on, is we always try to categorize a food as healthy or unhealthy. And I think there is room for foods that are neutral. And there is room for food that have neutral effects, that when you add all of these effects together, they contribute to specific nutrients and so on. But on their own, they're simply neutral, and it's okay. They don't all need to be favorable or deleterious. For specific dairy, there seems to be favorable effects in terms of health, maybe on their own. I believe it's almost impossible. You have to look at the replacement effect and the importance also in contributing to specific nutrients. I've talked about cardiovascular health, but there's the nutrient contribution of the foods, and dairy. For dairy, we talk about vitamin D, calcium, and so on, protein. Now, there's a lot of significant challenges in doing research in this area. Dairy is a complex mixture of a lot of things. There are proteins, there are different nutrients, there are micronutrients. And one of the challenges I see when I look at the literature is that people that are characterizing the association between high-fat dairy and health lump together high-fat milk and high-fat cheese. High-fat milk is 3% fat. Cheese is 40% fat or 45% fat. For me, these are not the same high-fat products. And in most cases, in epidemiological studies, they're lumped together into the high-fat category. So we can question ourselves, is that relevant? Is that okay? Is 3% fat a high-fat product? The fat composition of dairy varies according to feeding practices and seasons. And this is one example of a study published by the German group quite a while ago. But what they've done is they've looked at the fat distribution of milk in different settings. So indoor feeding practice of cattle, organic farming versus cattle being fed in the Alps at high altitude. And you can see that there is quite an important difference in terms of, it's a 10% difference in saturated fat content in the dairy fat from these different groups of cows. And this is nowhere being captured in the epidemiological data that we have. So some studies come from Europe. The cows that have provided the milk and the dairy fat in these studies come from different settings, different from the US. So this introduces a lot of noise in the data, and we have to keep that in mind. This is something that's completely underappreciated. The fortification policies also vary between countries. Some countries don't have vitamin D fortification as part of their practices. And again, when you do research in that area, what do you replace dairy with? Okay, so this is an important area to keep in mind. So I think in terms of the role of dairy, and this is my interpretation of the data that we have, there is room for dairy in a healthy dietary pattern. And in cohort studies, this data is supported as well. People that consume dairy tend to have a healthier dietary pattern. Now, one of the things that I think we need to reconsider is, why are we recommending low-fat dairy? Because there is no evidence that high-fat dairy creates a problem. So do we need to eat high-fat dairy or just low-fat dairy? At least based on association studies and what we have available, there's no, to my opinion, no evidence that low-fat is better than high-fat. So this is the group at our last disco party that I want to thank, because they are doing all the work. So my team of research assistant over the years, and the students. And I thank you for your attention, and I'm pleased to take questions.